Number 4 on the right triangles worksheet says angle B is 56 degrees, 48 minutes. And it says that side A is 63.1. Now, are these rounded? Are those rounded? No, those are exact answers. All the rest of our answers are going to be rounded. So do not use those other answers in when you're finding the other missing parts. First thing I want to do is, I like doing things the easiest, fastest way. You guys like that or not? You like doing the fastest, easiest way? So I'm going to use some old geometry stuff. Now, we had stuff in geometry that told me what about the 3 angles in every triangle. They always add up to 180, right? And then there's a corollary. A corollary says something that if you have a right triangle, the 2 small angles, the 2 acute angles have to add up to how much? 90, okay? You guys know what postulates are? Okay, postulate, also known as an axiom. Some books call them axioms, other books call them postulates. Those are things we assume to be true without proving. We take for granted that they're true, okay? And then there are theorems. Theorems are things where we use definitions and postulates and sometimes corollaries to prove they're true. Remember doing the 2-column proofs? Did you guys still do those? Okay, those are doing proofs for theorems. Corollaries are just like theorems. You have to prove them true, but they're easier to prove true than theorems. So in other words, you would know this because of the triangle sum theorem. That's where you'd start. And then you were given up here that angle C is equal to 90. I'm proving to you the corollary. So what that means is that A plus B by substitution plus 90 equals 180, which means A plus B by subtracting 90 from both sides, that's equality of subtraction, equals 90. This is the proof that the two acute angles add up to 90. That's a 4-step proof. Okay? You remember doing those? So this is the corollary, so that says these are always 90. So when I have a problem like this, I don't do SOH TOA to get my missing angle. I use that corollary right there. So in your calculator, you might type these degree in minutes in there. I don't do that. I put 90 minus 36 minus 48 over 60 is what I type in. And then I would DMS this. So why don't you guys see if you can get that to the nearest minute, because that's what you're going to have to do on the test. So do that on your calculator, see if you can get it. So, ooh, that works out all beautiful. I guess I should have though, shouldn't I? What'd you get?
53 degrees forward.
Did y'all get it? If you don't have your calculator, you're hurting yourself. Bring it every day. Question? You do not get to use the Chromebook on the quiz and test. Okay, so there's angle A. Now, normally this is rounded, so you should not use this one. Don't use what we just put up there. Use what they gave you. So again, I'm going to highlight what they gave me so I remember. I'm going to use these 2 things to find the other 2 parts. So now I got to ask myself, from this angle, what's the one that gave me? What's this? What's that leg called compared to that angle? It is not opposite. It's adjacent because it's part of angle B. It touches with vertex B. This other one's the hypotenuse. I'm going to find C first because that is opposite the right angle. Which one of these, or which one of those SOH TOA had those 2? Which one has A and H? Cos. So I'm going to go cosine of 56 degrees, 48 minutes is going to equal the adjacent A over the H, which is little c. Yes. Say what? I think so. Oh my gosh, I copied down the wrong thing. You're right. Sorry. A is not 63.1, so that is not given. Thank you. Little a, we don't know. We're given this one. C is 63.1. Thank you for straightening me out. Okay, so we're given a hypotenuse, so that takes this from there and moves it down here. And we're going to find A, which is adjacent. That is the adjacent. So that is going to be A up here. So now we're going to get little a, and you're going to type in your calculator 63.1 times the cosine 56 degrees, 48 minutes. Now again, I would type in 56 plus 48 divided by 60. If you notice, when I had a negative, I had to make both these minuses, right? Because the whole thing's negative. Since this is positive, I make it a plus there. I think this is faster than typing in with degrees and minutes symbols. So take 63.1 times cosine of 56 plus 48 over 60. And tell me what that rounds to 3 places, because we're going 3 decimals. Somebody, please. What? Everybody type it in. 63.1 cosine, and then 56 plus 48 over 60, parenthesis equals. What is it?
29.6,
29.6 what?
24.
24?
Yeah.
Anybody verify? You haven't typed it in yet?
No, I did. I just didn't get that. But I
Okay,
did.
hit your mode button. Are you in degrees?
Yeah, that's
Are you in degrees?
I figured that. That's no problem.
Huh? You did not get that? Lexi? You did not get that.
Oh, wait.
63.1 cosine.
Yeah.
56 plus 48 divided by 60, I get 61.118. Anybody else get 61.118? Yep, 61.118. Anybody else get that? Let me check my mode. Oh, I'm in radians. 34.551. How's that sound?
Yeah.
I didn't check my mode. If you don't have if you're not in the right mode, you're going to get the wrong thing. 0.551. Now, did we round this answer? So don't, we did. So don't use that in the next one. So now I'm going to ignore this thing. Come on, Pen. So now I'm done with this part. So I'm going to ignore this part, and I need to keep this part because that was given to me, and I should highlight that again. These were the 2 given, so I'm going to use those on everything. Now I'm going to look for little b. Where's little b over here from this angle? Opposite. So we're ignoring this one. We got O and H. Which one's got O and H? Sine. So I'm going to go the sine of 56 degrees, 48 minutes is going to equal opposite over hypotenuse. Now you want to show you a shortcut and typing this one in? Yes or no? Okay, do you realize that we just typed in exactly the same thing except it was cosine? Y'all notice that? Now watch this. Look, these calculators are pretty cool. At least I think they are. There wasn't anything like that when I was a kid, which was back when we had to drive the carriage, the horse wagon, the buggy and horse to school. Uphill both ways and 12 feet of snow. Okay, so you see I typed it in right there, right? Now watch, if I hit enter again, do you see it gives me the same thing? Oops. Why is it giving me the answer? I don't want the answer. Oh, second enter. You hit second enter. You hit second enter and it gives you the same thing. I can now arrow back to where cosine is. And now where I get on the C, if I hit sine, now it goes in and there's the answer without typing the whole thing back in. So 52.800 is what that would round to. 52.800. So there's the rest of the triangle. So you're given 3 parts and you're going to find 3 parts. You're always given the right angle is 90. Okay, and you're going to be given 2 of the other 5 parts, and then you got to find the missing 3. Do you follow what we're doing here? Now I'm going to tell you another thing. I wouldn't use CAH TOA if they gave me this. Oops. If I had my right triangle and they gave me this and this, I would not use CAH TOA to find that. What would I use? I'd use Pythagorean theorem. Well, I happen to know a 3, 4, and a 5 make up a right triangle, so I already know that's 5. Okay? So you can use geometry for shortcuts. Okay? If you know your rules. If you didn't study geometry and don't remember them, because I just studied for the test, man, I got a B. I just did the test. I don't remember anything. Then you've messed yourself over. And the higher you go in math, the more you're messed over, because you need all those other things to carry over to every other math class. I think I've told you this. You know what my calc kids miss the most? What they miss most on their tests and quizzes? My calculus kids. Take a guess. Anybody? It's not the calculus. Algebra 1. They haven't had Algebra 1 since 7th or 8th grade, and their algebra skills are not very good. The water pipe is under a horizontal lot. We just talked. What's a horizontal line look like? Yeah, it's like the ground, right? All right, so this is the horizontal lot right here. It says a pipe is placed under a horizontal lot at an angle of 2 degrees, 10 minutes. So I'm going to take the pipe and I'm going to put it under here at an angle of 2 degrees, 10 minutes. So there goes my pipe. So this angle is an angle of depression of 2 degrees, 10 minutes. It says, how deep must the trench be at a point 250 feet horizontally, 250 feet horizontally away from the part you're starting at. So which color has to be 250? Which segment color? The red, because it's horizontal again. This is 250 feet. And it says, how deep? Which part is how deep you're going to dig into the ground? The blue. Okay? How much piping is needed for the project? So this is asking 2 questions. It wants to know what's X, and then it wants to know what's Y. Because Y, the black line's the pipe. So I got to do this twice. So from this angle, what's this called? Adjacent. So I got to use an A in every problem because that's given. Let's find X first. What's the X called? Opposite. Which one has O and A? So the tangent of 2 degrees, 10 minutes is going to equal opposite over adjacent. And that will be the X value when you solve that. Okay, what's the Y value called right here? Hint, right angle. This is hypotenuse. Remember, we're going to use A and H. Which one's going to give us the Y value? If A and H, if it's adjacent hypotenuse. So the other end, it's cosine of 2 degrees, 10 minutes is going to equal adjacent over hypotenuse. Now you got to solve that one. Oops, I should have put Y because I used Y in the problem. If you put H, it wouldn't be bad. Can you all solve those algebraically? And then use your calculator? And you said number 9, right?
Yeah.
What's it? Can I erase this? Is it okay to erase now? Anybody still writing? Okay, here we go. An A-frame cabin. What's an A-frame? Anybody know what an A-frame is? One of my old high school friends, his parents had an A-frame house. Anybody know what an A-frame is? They're really funky looking, man. The roof goes almost all the way to the ground and comes up like this. It's got a real long roof like that. And then there's a deal of the first level comes across like that, and they got an upstairs and a downstairs. Anybody know why they call it an A-frame? It looks like a stinking A. Now there is down here, we're going to call that the ground, okay? An A-frame cabin is 25.69 feet high at the center. So do I have that drawn in here yet? I do not. So the center is going to come up to here. And that is so terrible. This is supposed to make these two equal. And I know it doesn't, but okay, those two are equal because it's the center. Does that make sense? And that whole black, I'm going to erase this because we don't need this in here. And this black part is what I say it was, 25.69 feet. By the way, it's perpendicular on both sides. All right. There's 40 feet, 40.52 feet wide at the base. So from here over to here is 40.52 feet. The whole base is 40.52 feet. What angle does the room make with the floor? So in other words, we're looking for an angle right here. And it's weird in those houses. I wouldn't want one. They take like too much space. Yeah.
Isn't there one on like Thompson?
Maybe, I don't know. I don't remember seeing it, but it could be. Yeah, it might be. I don't know. All right. Now, first of all, I want a right triangle, right? So I've got extra stuff over here that I want to kind of ignore. I don't care about this. I'm going to look at just this right triangle right here. Now, this whole base was 40.52, and this was the altitude. See, this and this are equal. It's an isosceles triangle. Does anybody remember what an altitude does to an isosceles triangle's base? Anybody know what we have to do with 40.52 to find this part of the right, this side? Cut it in half. So this is going to be 20.26. 20.26 feet. Now, I'm talking about this angle, right? The X. What is this side over here called at 25.69? Opposite. What's this side called right here? The 20.26. Adjacent. So this is tangent of the angle X is going to equal opposite over adjacent. Now, how do you get an angle? What do you got to do to get an angle on your calculator? How do you get rid of tangent? We did it in class last week. Number 2, on the paper you just turned in. What do you got to hit to get rid of tangent? Second tangent. That's inverse tangent. So you hit second tangent, it gives you that little inverse symbol there. And you type this into your calculator, and you're going to get some decimal answer. And then you have to hit DMS to round it to the nearest minute, because that's what I want you doing. That's what's going to be on your quiz and test, I believe. So will someone please tell me what you get on this? By the way, if you type this in right here like this, it'll give you degrees, minutes, seconds the first time.
51 degrees, 40.
51 degrees, 44 minutes. Does anybody else verify? Anybody else get the same thing, just to make sure? So whenever you're finding an angle, you must hit second trig function. That's the only time you hit second trig function, finding an angle. Did you get it? Great, I'll do it since 5.69 divided by 20.26. Second apps for, I get 51 degrees, 44 minutes. Is that what you said? Yeah, that's what I got. Did you get it?
Yeah, I just read it.
Anybody else? Okay, any others you want to see off any of these? How about the last 11? I am not going to do any more that I've already got videos of. 13. Scott Hardy stands 127 feet from the base of a bell tower. Anybody know what a bell tower looks like? Anybody? Okay, a bell tower is a tower that the bell's in the top of a tower. So in other words, a bell tower is up here and the bell is up here. So I'm going to put B for the bell in the tower. The bell's at the top. All right, so Scott Hardy stands 127 feet from the base. So let's make our right triangle. Which segment is 127 feet? Where's Scott Hardy? 127 feet from the base of the tower.
The horizontal. 127 feet.
Scott Hardy's what letter? A.
A.
The base of the tower is C, so that's 127 feet. The angle of elevation. Which angle is angle of elevation? A, B, A, or B? A. This is 21 degrees. Find the height of the tower. Do I need to do more than that now? Can you finish that? SOH or TOA?
So,
TOA. Axis opposite, 127 is adjacent. Any others you want me to draw for you? I told you drawing them's the hardest part.
Can you do 17?
17? I can do them all, I hope. I think I just did 17 this morning. Did I say 17 or not? Huh? Okay, we'll do 17. I think I did it this morning, but we'll do it again. The angle of depression from the top of Pikes Peak. So here's Pikes Peak. I'm going to put PP for Pikes Peak. So Pikes Peak, since it's a peak, tells me that it's up in the air somewhere. And I got something somewhere. I could have drawn it the other way, doesn't matter. Angle, I'm going to draw my hypotenuse. Pretend that's a straight line. Angle of, where is it? 17. The angle of depression. Where does an angle of depression go? Here?
oh,
No. Angle of depression comes out here, right? It's not in the triangle up here. So the angle of depression was 8 degrees coming down. Now this is Colorado Springs over here. So the angle of, and what else equals 8 degrees besides the depression? What's exactly the same as the angle of depression? So I'm going to put the 8 degrees down here because they're alternate interior angles. Okay, so what else we got here? At an altitude of 14,000 feet to the city of Colorado Springs, the angle of depression at the top of Pikes Peak at an altitude of, so this is 14,000. Actually, it's not. This is 14,000. From here all the way down to sea level. There's somewhere down here that is sea level. So this is kind of like the other one we drew a little while ago. This is sea level down here. Okay, it says horizontal distance from the city to the peak is 58,000 feet. Okay, well this problem is done wrong. All right, this problem is done incorrectly here. The angle of depression at top Pikes Peak at an altitude of 14,000 feet to the city of Colorado Springs is 8 degrees. The horizontal distance of the city to the peak is 58,000. Find the altitude of Colorado Springs. Okay, so this 14,000, they are saying this is 14,000, my bad. All right, so we got this look right here. I have to find this height to get this height, which is going to be the same as that height. Y is what I'm looking for. What is the altitude of Colorado Springs? So you got to get this X first. So isn't this opposite? X is opposite. Isn't this adjacent? So you got to do tangent of 8 degrees equals X over 58,000. And then you're going to get X equals 58,000 times the tangent of 18 degrees. So that's going to be some number. Now, how am I going to get this Y value down here? If this X is from here, from there up, how am I going to get Y once I get X? Segment subtraction again, you see it? 14,000 minus the X you get is going to be the answer we want, that is the same as the Colorado Springs altitude. Okay? Any others? All right. We got the rest of the period to work on. Oh, I got to tell you something else too. Shoot. I know, I got to shut off this video.